We're looking at homework from section 6.4. This is question number 8. The waiting time in minutes of a random sample of 21 people at a bank have a sample standard deviation of 3.7 minutes. Construct a confidence interval for the population variance sigma squared and the population standard deviation sigma. Use 95% level of confidence. Assume the sample is from a normally distributed population. So, we need the sample standard deviation, which was given to us as 3.7 minutes. Now we need to find the chi-square values for a confidence level of 0.95 and a sample of size 21. Drawing a picture might help us get a better idea of what's going on. So we have our chi-squared distribution, which is a non-symmetric distribution, and we place chi-squared L and chi-square R in such a position that the level of confidence, 0.95, is the area trapped between them, and that the two tails have equal area. So if the area in the middle is 0.9500, that's 95%. That leaves 5% of the total area to be split evenly between the two tails. So each tail will have 2.5%, which is 0.0250. The way that the chi-square distribution works is we're looking for area to the right of each chi-square value. So to the right of the chi-square L value, we have the area 0.9500, the central area, and then the right-hand tail area of 0.0250 for a total area of 0.9750. For chi-square R, the area to the right of that value is only the right-hand tail, which is 0.0250. So we'll keep this diagram as reference, and then we'll ask these questions. What is the area to the right of chi-square L? We said it's 0.9750. What's the area to the right of chi-square R? We said that's 0.0250. And then what are our degrees of freedom? Degrees of freedom are one less than the sample size, so that would be 20. Now we can use that info to find the chi-squared values. We're going to use the chi-square distribution table. So let's recall our values. The degrees of freedom is 20. The area to the right of chi-square L is 0.9750. The area to the right of chi-square R is 0.0250. And then to find chi-square L, we look for our degrees of freedom in the left-hand column, 20, and then the area to the right of chi-square L, 0.975 across the top. That gives us a value of 9.591. For the chi-square R, we do something similar, but we look for the 0.025 across the top because the area to the right of chi-square R was 0.0250. That gives us a chi-square R value of 34.170. Now that we've got these values, we can move on to the confidence interval. So the values we need for the confidence interval are the degrees of freedom, the standard deviation, and the chi-squared values. The formula for the confidence interval for the variance is sigma squared is between n-1 s squared over chi-squared r and n-1 s squared over chi-square L. Notice the n-1 is your degrees of freedom, the s is your standard deviation, and then we have our two chi-square values. The chi-square r value is on the left and the chi-square L value is on the right. At first this may seem counterintuitive, but it actually makes perfect mathematical sense. Chi-square r is further to the right on the x-axis than chi-square L, which means that chi-square r is a larger value. When you put a larger value in the bottom of a fraction, that makes the value of the fraction smaller. So that means the fraction on the left-hand side of this inequality is a smaller number, and the fraction on the right is a larger number, so the inequality can be true. We're going to go ahead and insert these values where they belong. 20 times 3.7 squared over 34.170 is less than sigma squared, which is less than 20 times 3.7 squared over 9.591. Simplifying on the calculator, we find that s squared is between 8.012876793 and 28.54759671. Rounded to one decimal place, we get 8.0 to 28.5. That's our confidence interval for the variance. Let's go ahead and interpret those results. Remember that when we're finding a confidence interval, the level of confidence tells us how certain we are that the population value, in this case sigma squared, falls within the boundaries of our interval. So we're 95% confident that sigma squared will be between these two numbers. That eliminates choice C and D, which say we're only 5% confident. So we look at choices A and B, and the only one that has the value falling between two entries is choice A. So our answer here is choice A. With 95% confidence, you can say that the population variance is between 8.0 and 28.5. Let's move on to the standard deviation. We've done a lot of work for the variance, and thankfully, we get to use all of that work to help us with the standard deviation. Remember the relationship between the variance and the standard deviation. The standard deviation is always the square root of the variance. So if we take the inequality statement that we had for the variance, and we take the square root of each part, we'll get the confidence interval for the standard deviation. So here's our confidence interval for the variance. We take the square root of each part, square root of sigma, square root of sigma, and when we simplify those square roots, we have this confidence interval, which now is for the standard deviation. We round this to 1 decimal place, and we get a confidence interval of 2.8 to 5.3. That's your confidence interval for the population standard deviation. You should run a check at this point in the problem to make sure that you're right. How do we do that? We have to make sure that the initial standard deviation for the sample we had falls within this interval. The initial standard deviation was 3.7. So 3.7 does fall between 2.8 and 5.3, so we feel good about our estimation here. It won't be exactly in the center because the point estimate for the standard deviation doesn't fall in the middle of its interval, but it will be within the boundary of the interval. So since 3.7 does fall between these numbers, we feel good about it, and we'll move on to the interpretation. Remember, with a confidence interval, the level of confidence is how certain we are that the actual population value, in this case sigma, falls between these two values. So that eliminates choices A and C that say we're only 5% confident because our level of confidence was 95%. And the only choice that has the value between two other values is choice B. With 95% confidence, you can say that the population standard deviation is between 2.8 and 5.3 minutes. And that's your answer.